In the last video, we saw how we can save our existing trained model to a file and then load it back in and then make some predictions that get the exact same results as the original model that we saved to file. We used Pickle to do that. In this video, we're going to see how we can do the same thing with the joblib module. And again, if you don't know something, you can always go, what is joblib? Joblib, running Python functions as pipeline jobs, and you could go through the documentation here to see how you do it. But let's just see an example of how we do the exact same thing here with the joblib module. So create a heading, go joblib. Change that to Markdown, hit Shift and Enter. So the first thing that we're going to do, we can go from joblib, import, dump, and load. You might be able to guess what these two functions do. So to save model to file, we'll go dump GSCLF because we're going to save the exact same model that we did with Pickle. So our grid search classifier. We're going to pass it file name. And we'll go gs random forest model1.joblib. So that's the difference here. We can pass it a file name. Oh, we have to push equals. With Pickle, we use .pkl, which is short for Pickle, of course. But with joblib, we do .joblib. And so now if we hit Shift and Enter there, it's going to give us a little output here. Now, if we go back to our working directory, we'll see the same thing. So seconds ago, we have gs random forest model1.joblib. And again, you can change this file name to whatever you want. See, now we've got about half a dozen models just sitting in our working directory. At this point, we might move them into a models file. So we come back here. Now, if we wanted to load in our joblib model, you can probably guess which function we use to do that. If not, we're going to go through it. So we'll go import a saved joblib model, and we're just going to import the exact same model that we saved. So loaded joblib model equals load file name. We just have to pass it the exact same file name as what we saved it as. So gs random, we should be able to hit tab autocomplete, .joblib, wonderful. So that's going to load it in. Oh, what have we got here? Oh, we missed an inverted comma. File name. We're making typos left, right, and center, even using tab autocomplete. Beautiful. And again, once imported, we can make predictions with our loaded model. So let's see it again. Make and evaluate joblib predictions. Joblib y preds equals loaded joblib model.predict xtest. Wonderful. And then once again, we'll use our evaluate pred. See how this has come in handy? We defined this function a few videos ago, but now we've used it at least half a dozen times, and so preventing us from having to type out a bunch of different code, the same code over and over again. So joblib y preds, Shift and Enter. We should get loaded joblib model is not defined. Where are we making this? It's a loaded job model. We might change that to joblib, and then this should work. Wonderful. So if we compare this is with joblib, these are with Pickle, 78.69 tick, 0.74 tick, 0.82 tick, 0.78 tick. So it's again the exact same thing with joblib as Pickle. And now, which one should you use? Well, according to scikit-learn's documentation, let's have a look. Scikit-learn exporting a model. Exporting a model persistence. That's the word I was looking for. So again, if you're thinking of something that you're trying to do with a library, right, just search the name of the library. This is exactly what I do. I typed in scikit-learn saving a model. That's what I wanted to do. I'll come up to the documentation. After training a scikit-learn model, it is desirable to have a way to persist the model for future use without having to retrain. That's the main benefit of saving a model, right? So here's an example. So you can use Python's built-in persistence model, Pickle. That's what we've seen. And now you could also use, in the specific case of scikit-learn, it may be better to use joblib's replacement of Pickle, dump and load, which is more efficient on objects that carry large NumPy arrays, internally, as is often the case for fitted scikit-learn estimators. And that's what we're saving in our case, right? We're saving a fitted scikit-learn estimator, aka GSCLF, which is our fitted grid search random forest classifier. but can only pickle to the disk and not to a string. So what this is saying is essentially, sometimes if your model is large, it might be more efficient because a model is made up of large NumPy arrays, aka patterns in numbers. That's what these NumPy arrays are internally full of. That's what our classifier is probably full of, just different NumPy arrays with patterns between them. That's what it's learned from the data. So what this is saying is that if your model is large, in our case, our models are relatively small because we're only working with 300 or so samples. But if it is large, it may be more efficient to use joblib over pickle. That's the main thing to worry about there. Alrighty. So that's the crux of saving and loading a trained model. Again, we've got them stored in our directory here. If we needed to share this model, that's something we could pass on to our production application or to our colleagues so they could replicate our work or something like that. Now, we're really on the home stretch. Next, we're going to, let's check back at our list. We're going to check out how we can put it all together. I won't spoil anything before the next video. So have a quick break, try to save one of the models that we've trained using joblib or pickle, and I'll see you in the next video.